Um, I always find that robot weird. Okay, anyhow, and I always like to start off any Zoom session with a fractal, such as this one, because I made these, and I think they're pretty. So there we go. This this Zoom session is being brought to you by the fractal crystal ball. Oh, I have a cat. All right, and today we'll be starting on doing on sections 1, 1, and 1, 2. Okay, cat. Of course he comes in right now. Excuse me, I have to chase him out. Hey, cat. Charlie, here you go. That's what happens when I leave the office door open. The cat comes in and demands a treat. I throw it out the door. He runs out the door. I close the door after him. The cat and I have each other well trained. Anyhow, so in section 1, we'll talk about the distance and midpoint formulas. All right, we start with the Cartesian plane. The idea of the Cartesian plane is that for every point on the plane, we will associate a pair of numbers. We do this by drawing two lines called axes at right angles. And this is the x-axis, this is the y-axis. For any point, we drop a perpendicular to the x-axis and to the y-axis, so we get this rectangle here. This P is at a distance x to the left or right, and y up or down. So its coordinates are x by y, an ordered pair. Ordered because x by y is not the same point as y by x. Okay, so given 2 points in the Cartesian plane with coordinates x1 by y1 and x2 by y2. 2 questions are: 1, what is the distance between the points? And what are the coordinates of their midpoint, M? Okay. Midpoint formula is really pretty simple. Given 2 points in the plane, this point is at x1 by y1, this point is at x2 by y2. Then M has coordinates, x coordinates, y coordinates that are midway between the x and y coordinates for these other points. So its coordinates are the averages of the 2 points coordinates. If this is x1 and this is x2, their average is their sum over 2, x1 plus x2 over 2. This midpoint between y1 and y2 is their sum over 2, y1 plus y2 over 2. So its coordinates of so you can think of M as the average of the other 2 points. So for example, 3 by 4 and 5 by negative 4. What is its midpoint? Well, x coordinate is 3 plus 5 over 2 here, and y coordinate is 4 plus negative 4 over 2 here. 3 plus 5 over 2 is 4. 4 plus negative 4 over 2 is 0, so the midpoint is 4 by 0. Now, for finding distances between 2 points, we go back to a classic theorem, thousands of years old, and it has some interesting stories behind it. The Pythagorean theorem. The stories are because of that brilliant lunatic Pythagoras. Perhaps I'll say more about him at another time. Anyhow, his theorem was about right angle triangles. That's a triangle with a 90-degree angle here. We'll be seeing a lot of those over the course of this semester. And it has sides A, B, and C. And the theorem says that a squared plus b squared equals c squared. The square of the sides sum to the square of the diagonal. Now here's a not exactly a proof, not to Greek standards, but it's a demonstration up to South Asian standards. A mathematician from India drew this diagram in his book and wrote below it one word: behold. The idea being is that here's a big square with side a plus b. And here's another square of the same side a plus b. Now here we draw 1, 2, 3, 4 triangles with sides A, B, and diagonal C. Here, 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 and here. And now it's clear to see that this is a square with side A, so it has area A squared. This is a square with side B, it has area B squared. Now we move these 2 triangles here and here, and these 2 triangles here and here. And then, okay, you have to do a little bit of angle measuring to figure that this is a right angle, as is this, and this, and this. So this in the middle is a square with side C. So it is area C squared. Same big squares here and here. Same 4 triangles here, 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 and here. Therefore, the remaining areas must be the same. Therefore, a squared plus b squared is an area equal to this area, c squared. One classic example is the 3, 4, 5 triangle. 3 squared plus 4 squared is 9 plus 16 is 25, and that's 5 squared. 3, 4, 5 triangle. Now, okay, we can immediately use the Pythagorean theorem to talk about the distances between 2 points in the Cartesian plane. Given 2 points here and here, x1 by y1 and x2 by y2, what is the distance between them? Well, we draw this line parallel to the x-axis and this line parallel to the y-axis, so therefore they'll be at right angles. This point is at x2, this point is at x1. This distance, this horizontal distance, is therefore the difference, x2 minus x1. This point is at height y2. This point is at height y1. So therefore, the distance between the difference of their height is y2 minus y1. So you have this side here, x2 minus x1, and this side here, y2 minus y1, and the diagonal d. Therefore, by the Pythagorean theorem, d squared equals x1 minus x2 squared plus y1 minus y2 squared. And then square roots, d is the square root of the sum of the squares of the differences of these coordinates. That's 4 ofs in a row. Square root of sum of squares of differences of coordinates. So for example, given a point -2 by 15 and another point -7 by 3, what's the distance? Well, distance is the square root, the sum of the squares of differences. -2 minus 7 goes here. 15 minus 3 goes here. -2 minus 7 is a 5. 15 minus 3 is a 12. 5 squared plus 12 squared. Square root. 5 squared is 25. Square root is 12 squared is 144. These sum to 169. And the square root of 169 is 13. So there's another right triangle, the 5, 12, 13 triangle. In fact, there are quite a few. So we have some examples. Given 2 points, what is the distance between them? Okay, fine. The distance is the square root of the sum of the squares of differences. 3 minus 5 here, -4 minus 4 here. 3 minus 5 is a -2, that's squared. -4 minus 4 is a -8, square that. -2 squared is 4, -8 squared is 64. Square root of 4 plus 64 is root 68. We can simplify this a little bit because 68 is 4 times 17. So we break the square root into 2 square roots. Square root of 4 is 2, and so the distance is twice the square root of 17. Here we have 2 points, -3 by 2 and 6 by 0. What's the midpoint? Well, the midpoint is average coordinates. -3 plus 6 over 2 for the x value, 2 plus 0 over 2 for the y value. -3 plus 6 over 2 is 3 halves. 2 plus 0 over 2 is 2 halves. And so this becomes 1.5 by 1 is the midpoint. What points on the x-axis, this question asks, are 6 units away from 4 by -3? Okay, first, a point on the x-axis has coordinates x by 0. So what we need is a number x. This x by 0 point is 6 units away from 4 by -3. So x minus 4, square that. 0 minus -3, square that. The sums to 6 squared. All right, so x minus 4, well, 0 minus -3 is 9. And 6 squared is 36. Transpose the 9 and get x minus 4 squared is 36 minus 9. That's 27. So solving by square roots, x minus 4 is plus or minus root 27. And 27 has a factor of 9 in it, root 9, root 3, root 9 is 3. So x minus 4 is plus or minus 3 root 3. Then adding 4 to both sides, you get x is 4 plus or minus 3 root 3. So there are 2 points. X plus 4 plus 3 root 3 by 0 and 4 minus 3 root 3 by 0. Both are 6 units away from 4 by -3. Here, this is a tricky one because it's a reverse problem. Instead of given 2 points and the midpoint between them, we're given 1 point and then midpoint, find the other point. So we have to be a little careful. P1 is -3 by 6. The midpoint between P1 and P2 is -1 by 4. What's the second point, P2? We do not want the midpoint between these two. We want the second point, which makes this the midpoint between it and that. Okay, we want to know what P2 is. Let's say it's X by Y. So P2 and P1 have midpoint -1/4. Negative midpoint will be first X coordinates X minus 3/2 here. Y coordinate Y plus 6/2 here. That midpoint is -1/4. So these coordinates are equal, and these coordinates are equal. X minus 3/2 is -1, and Y plus 6/2 is 4. All right, solve by transposing the 2 and the 2. X minus 3 is -2, Y plus 6 is 8. Add 3, subtract 6. You get X equals 1, Y equals 2. So the second point is 1/2. Here we have 3 points, -2 by -1, 0 by 7, and 3 by 2. Is P1, P2, P3 a right triangle? Is it an isosceles triangle? A right triangle is one with a 90-degree angle at a corner, and it will obey the Pythagorean theorem, a squared plus b squared equals c squared. An isosceles triangle is a triangle with 2 equal sides. So the thing to do is find the distances between these points. Distances from P1 to P2, from P2 to P3, from P3 to P1. That's what we have here. P1 to P2, all right, we do a bit of the arithmetic, blah, 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 blah. You get root 68, which is twice root 17. From P2 to P3, using these numbers and to the formula, you get root 34. And P3 to P1, that's between these two numbers, do the arithmetic, get root 34. Well, what do you know? These two sides are equal, root 34. So it's an isosceles triangle. And what's more, root 34 squared plus root 34 squared is root 68 squared. So it's a right triangle. It's a right isosceles triangle. So it's a triangle with 2 equal sides joined at a right angle. So it's both. Here's a picture of a baseball diamond. It's a diamond, really it's a square tilted 45 degrees, 90 feet on a side. How far is it from home plate to second base? Okay, here we have a right triangle, and in fact, an isosceles right triangle. Side 90 degrees, 90 feet here, 90 feet here, right angle here, and distance d here. Well, okay, by Pythagoras, d squared equals 90 squared plus 90 squared. That's twice 90 squared. Take the square root, root 2 times 90 feet. So the distance is 90 root 2 feet, which is approximately 127.28 feet. That's a bit too precise for now. I mean, a hundredth of a foot is a fraction of an inch, which of course is absurd, but seeing as those plates are about a foot across themselves. But I suppose so really 127.3 is probably all the accuracy that's really required here. Let that be. Here we have 3 points, -2 by 5, 1 by 3, and -1 by 0. Prove that it's a right triangle. What is its area? Well, all right. We find the distance from A to B, B to C, C to A. A to B, -2 minus 1 squared, 5 minus 3 squared, that's 9 plus 4, makes 13. From 1 to 3 to -1 to 0, 1 minus -1 squared, plus 3 minus 0 squared, it's 4 plus 9, again 13. And then CA, -1 minus -2 squared, plus 0 minus 5 squared. That comes out to 1 plus 25 is 26. And what do you know? AB squared is 13, BC squared is 13, CA squared is 26, 13 plus 13 is 26. So yes, we have a Pythagorean, it's a right triangle with a right angle at B. Now the area of a triangle is 1/2 base times height. All right, 1/2 times AB, which is root 13, BC, which is root 13, here and here. Multiply it out, you get 13 halves. Just a moment. I misspelled highlight. I have to change that later. Okay, that's that for that. Stop.